everybody. Today we're doing the Molecular Modeling Virtual Lab. And to do this, we're going to be drawing Lewis structures, comparing those Lewis structures to a 3D model, and see if that will help us to understand the shapes and bond angles of some of these molecules. So to start off, you will have a molecular modeling kit. This one's a little empty because I used it to make some other models. And we're going to tie these in by making our Vesper shape and then building the model, making our Lewis structure, building the model, and then going from there. So a couple things from this molecular modeling set, you will have a list that tells you which colors to use, how many you should have per box. So you do have to check your box at the end of the lab to see if you have enough of each part, because this is how many should be in each one. And then it just kind of tells you, gives you an idea of how you need to build these models. So some particulars, which you will see in a second when I build two of these examples for you, so I'm not building all of them, but I will build two, is that you have these thick bonding parts. These are for single bonds. Then if you were to have double or triple bonds, you're going to use these longer molecule bonds because they're more flexible, so they actually can make it where you can bond your atoms together. So the first example we're going to do is CCl4. This is the first one in your chart. So your job is to draw the Lewis structure first, see what kind of bonds should form, which would tell you if you're going to use a thick or a flexible bonding part. And then you're going to build your molecule with the sets. So our first one, like I said, is CCl4. Okay, so for CCl4, carbon, we know, has 4 valence electrons. Each Cl has 7 valence electrons, but there are 4 of them. Okay, so we're going to add these up, and that's going to help us to know so we can draw our bonds correctly. I will say, on your molecule kits, you will not see lone pairs. So that is going to adjust your shape a little bit. On some of the pictures that you'll see in this lab, I did actually add in lone pairs for you so you could see how that would adjust this shape. Okay, so we've got 28 plus 4, we've got 32 valence electrons that we're looking at. We're going to draw our dots. So we know carbon, let me lower this a little bit. Carbon, we know based on its Lewis dot structure, should have 4 dots. Each chlorine should get 7 dots. Okay, then, just like we've learned, you're connecting dots. You're giving each electron a buddy between 2 atoms. So these 2 can partner up, these 2 can partner up, these 2 can partner up, these 2 can partner up. All right, so based on this Lewis dot structure, you have 4 electron domains. You have 0 lone pairs, which means you should have a tetrahedral geometry, because that is the electron geometry for 4 electron regions. So you're going to have a tetrahedral geometry with a 109.5 bond angle, which is all information you need on your data chart. So now let's build it and let's see what that looks like. So based on your chart, this black ball is carbon, and we're going to put our 4 single bonds on there because our Lewis structure showed single bonds. And then the greens are halogens, which are chlorines, fluorines, bromines, and iodines. So based on your Lewis structure, CCl4 looks like it's a flat molecule. However, it actually is a 3D molecule that looks like this. And this helps you to understand symmetry and polarity as well. This molecule, if you look down this axis, in every direction that you split it, it is a symmetrical molecule. Since it is symmetrical, this actually will lead to a non-polar molecule. If one of these little dots was different, or you were not able to split it into all symmetrical points, then you have an asymmetrical molecule, which means it is polar. Really pay attention to lone pairs, because lone pairs will throw off your symmetry. It will make it where it's non-polar. It will make it where it is polar. Okay? Even though it might look non-polar without the lone pairs. So the next example we're going to do is N2, further down on your chart. Okay, so each nitrogen we know has 5 valence electrons. So like this. Okay, so we're just going to connect the dots between the two that don't have buddies. So when we do this and we redraw our molecule, you should see that you have a triple bond between the two nitrogens. The reason I wanted to show you this one is so you know how to use the flexible pieces. So you've got the flexible bonds now. So we've got 2 of them together. That's a single bond. So that would be a double bond, and we've got 1 more. Maybe. And this one shows our triple bond. So it's got 3 bonds between the two. When you look at this one and you look at your dot structure, you can tell there are no branches off of either of these. We do not have a central atom. When you don't have a central atom for covalent molecules, you automatically know that your shape is linear with a 180-degree bond angle. Now, looking at this one as well, since both sides have lone pairs, they're going to pull equally away from each other, which would also make this one a nonpolar molecule. So now that you've seen these 2 examples, I want you to go through and finish your data chart, and I have attached photos to the instruction sheet.